Questions 11 through 20 on the 2021 Grade 7 Gauss Math Contest. Layla writes a list of numbers. Her first number is 4. Each number after the first is 7 more than the previous number. Which of the following numbers appears in Layla's list? 4, and then we keep adding 7, right? So it'll be 11, then 18, then 25, then 32, then 39, and then 46. So 46 will appear in her list. Therefore, number 11, the answer is B. The letter A has a vertical line of symmetry and the letter B does not. How many of the letters H, L, O, R, X, D, P, E have a vertical line of symmetry? H does, right down the middle. O does, right down the middle. And X does, right down the middle. And I think those are the only 3 letters of these letters that have a line of symmetry, vertical line of symmetry, that is. Therefore, number 12, the answer is C. In the diagram, A, B, and CD intersect at E. If triangle BCE is equilateral and triangle ADE is a right angle triangle, what is the value of X? This is equilateral, so this would be 60, 60, and 60, the degrees. With opposite angles, we can say that that is also 60. So there we go. We have all 3 angles of that triangle DAE. One is X, one is 60, and one is 90 degrees, since that symbol is 90 degrees. And all of those angles, of course, have to add up to 180. And when you solve that, you get X equal to 30. So number 13, the answer is E. Which of the following is the sum of 3 consecutive integers? 3 consecutive integers would be X, X plus 1, and X plus 2. The sum, you would add them. And when you do, you get 3x plus 3. You can factor out a 3 here, and you get 3 times x plus 1. So the sum of 3 consecutive integers is obviously some multiple of 3. 3 times x plus 1. Which of these numbers is a multiple of 3? The only one is D. Number 14, the answer is 21. A positive integer whose digits are the same when read forwards or backwards is called a palindrome. An example of a palindrome is 13931. What is the sum of the digits of the next palindrome greater than 13931? We have to play around with this and see what is the very next palindrome. Do I have to change the 2? Meaning, do I have to change the first number? If I do, I go from 13,000 all the way up to 23,000. That's a very big jump. I'm positive that we can find a palindrome much smaller than that. I don't think we need to change the 1s. I think I'll concentrate on changing the 3s. What can I do here? If I make that a 4, that will work, but then what do I put in here? The very next palindrome would be if I put a 0. And this is the right answer. Now, they want the sum of the digits of that. So the sum of the digits of that looks like 1 plus 4 plus 4 plus 1, and that is, of course, 10. So number 15, the answer is D. The number 6 has exactly 4 positive factors, and the number 9 has exactly 3 positive factors. How many of the numbers in the list 14, 21, 28, 35, 42 have exactly 4 positive factors? There is a trick or rule, whatever you want to call it. If you take a number like 14, for example, right, and you break it into its prime factors, the number of factors will be calculated as follows. It's a really easy tool, actually, and very helpful. Take this number and add to it 1. And then you multiply it by taking that number and add to it 1. Now this becomes 2 times 2, and 2 times 2 is 4. So 4 is the number of factors of 14. So let's do the same thing with 21. 21 is 3 times 7, correct? So it would again be the exact same thing. 1 plus 1 times 1 plus 1 and that is, of course, 4. So this one and this one, both of those seem to have 4 factors. How about 28? 28 is 4 times 7. But 4 times 7, remember, it's got to be broken down to its prime factors. If you do that, it's 2 to the power of 2 times 7 to the power of 1. Now, if you use that rule, it would be 2 plus 1 times 1 plus 1, and that is 3 times 2, which is 6. So that's different. 35. 35, if you break it into its prime factors, is 5 times 7. And that, using the rule, would be 1 plus 1 times 1 plus 1, and that is, again, 4. Okay, 35 has 4 factors. What about 42, the last one? That's 6 times 7. 6 is not a prime number, so it's got to be 2 times 3 times 7. So using this rule, it would be 1 plus 1 times 1 plus 1 times 1 plus 1. That's 2 times 2 times 2, which is 8. So the only ones that have 4 factors are 14, 21, and 35, and there's 3. So number 16, the answer is C. The original price of a shirt is reduced by 50% to obtain a second price. The store advertises an additional sale, and so this second price is reduced by 40% to obtain a third price. What is the discount of the third price of the original price? Let's just say the original price is $100. When we do that first discount, 50%, we bring the price down to $50. And then we're doing a second discount, but this time 40% of this price. So 40% of 50, well, 10% is 5, so 40% would be 20. So I've got to take $20 off, so now I'm down to $30. And now they're saying is what is the percentage as you went from the original price to the very final price, which they are calling the third price. Well, when you go from 100 to 70, obviously you drop down by 70%. And therefore, number 17, the answer is C. In the diagram, triangle ABC is isosceles. M is on BC, so that BM is equal to MC. If the perimeter of ABC is 64, and the perimeter of ABM is 40, what is the length of AM? Let's label this. Let's call this X. That is also going to be X, since those symbols indicate that those are the same. From B to M, I'll call Y. Therefore, from M to C will also be Y. And from A to M, I'll just call it Z. So based on the information they gave me in the question, the perimeter of ABC is 64. So that means that 2X plus 2Y is 64. Therefore, X plus Y is 32. And then the perimeter of ABM is 40. So that means X plus Y plus Z is 40. So that means 32 plus Z is 40. And therefore, Z is equal to 8. And Z is what I had chosen to represent AM. Therefore, number 18, the answer is B. Two different digits from 1 to 9 are chosen. One digit is placed in each box to complete the two-digit numbers shown. The result of subtracting the bottom number from the top number is calculated. How many of the possible results are positive? Okay. We have to choose two different numbers from 1 to 9. Okay, so let's start with 9 and then work our way down. Let's say I chose 9, so that would be 59 minus something with a 5. What are my choices? Can I put here 1, yes, 2, yes, 3, yes, 4, yes, 5, yes, also. But once you get to 6, the result will not be positive. And that's what they're looking for. Because if I put a 6 here, it will be 59 minus 65, which is negative 6. So I can't put a 6. These 5 are the only choices. So I put a little bracket, 5 choices there, 5 ways of doing that. That was when I chose a 9. All right, so let's have the same scenario. What happens when I put an 8? It's the same story here. 1, 2, 3, 4, 5, all qualified. The 6 would make it negative, again 5. Same story holds when you choose the 7, 1, 2, 3, 4, 5. And the same story when you choose a 6, 1, 2, 3, 4, 5. But when you choose a 5 as the number to go there, then we have a limited choice. You can put a 1 here, or a 2, or a 3, or a 4, but you can't put a 5 because they have to be two different digits. You can't choose the 5 twice. So here now we have only 4 choices. So that's all this is. This is the only game we have to play. So far I've chosen the 9, 8, 7, 6, 5, and I guess I have to get to 4 now. So 5, 4, and then we've got this 5. Now I can put 1, 2, 3. I can't put a 4 because I already chose a 4, and then if I put a 5, it would become a negative. So here there's only 3 actually choices. How about for 3? If I put 3 as that number, it's the same kind of story. I can put a 1, a 2. I can't put a 3 because I've already chosen the 3. I can put a 4, but I can't put a 5. So another 3. And it's the same story for 2. You can put a 1, a 3, or a 4. And finally, the last one is when it's a 1. You can put a 2, a 3, or a 4. So we have 5, 5, 5, 5, that's 20, 24, and then 3, 3, 3, 3, another 12. 24 plus 12 is 36. Number 19, that would be A. Two standard dice are rolled. What is the probability that the sum of the numbers on the top faces is a prime number? You're only rolling 2 dice, so each dice, since it has only 6 possible choices, 1, 2, 3, 4, 5, 6, as what number could appear. There's 6 times 6 possible outcomes. 6 for the first dice, second for the second die. And since 36 is not that many, we can write them all out. So for example, if the first die is a 1, the second die could have any of the following numbers, right? 1, 2, 3, 4, 5, 6. And the sum we can easily make 2, 3, 4, 5, 6, 7, like that. So I'll just write them all out and then come back and talk to you. So here's the full list, right? Here's the 36 possible combinations, and these are all the sums. So pretty easy to make these lists, actually. Now we have to figure out, of those 36 sums, how many are prime. Okay, let's circle the primes. 2, 3, 5, and 7. Those are prime. 3, 5, and 7. 5, 7, 5, 7, 7, 11. 7, 11. Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 out of the 36 possibilities. And in lowest terms, divide top and bottom by 3, 5 over 12. Number 20, the answer is A.